Continuing with our discussion of what a partition and what a partition is, what it represents, the information about it. A partition. A partition has two notions associated with it. One is called the norm of the partition, and another is a refinement of the partition. So, the norm of the partition, the refinement of the partition. Now, let's suppose, let's do a specific case here, or sort of a specific case. Suppose this is x0, suppose this is x1, this is x2, x3, x4, and x5. So in my case, n is equal to 5. And so those are just the points I've selected. Let me draw these in color, maybe they'll show up a little bit better. So that's my partition of my interval. The norm. Well, look at the subintervals I have created. So the subintervals. The subintervals. Well, the first subinterval goes from x0 to x1. Typically, we list the subintervals as closed intervals. And then this is subinterval number 1. And then subinterval number 2 goes from x1 to x2. Subinterval number 1, number 2, number 3. So x2 to x3. Number 4 goes from x3 to x4. And number 5 goes from x4 to x5. Now, you don't need to be able to reproduce this. You won't be required to generate this. I'm just showing you what these ideas are, what they correspond to in this picture. But we have these subintervals. Now, one small detail. We can see why we start with x equals, with x subscript 0 here. X subscript 0 is the first point because when I say subinterval number 1, it goes from x0 to x1. Subinterval number 2 ends at x2. Subinterval number 3 ends at x3. Now, suppose we had numbered this x1 instead of x0. This would have been 1, 2, 3, 4, 5. This would have been x6, which means the last interval would have ended at x6. And so the number of subinterval and it doesn't match up well. And so for that and a few other technical reasons, we start at 0, and then this interval, the subscript of the right endpoint, corresponds to the number of subinterval. X1, x0, x1, interval number 1. Interval number 3, x2, x3. So if we had a much larger partition, suppose we had, instead of having just n equal 5, suppose we had n equal 20. We could then, knowing this, so if n were equal to, say, 20, then if we want subinterval number, let's just pick one out of the blue sky. We want subinterval number 14, we know how to represent that. Notice that subinterval number 3, the right endpoint subscript is 3. So if I want subinterval number 14, that would correspond to, you tell me, that would have been x sub 13 to x sub 14. This is the 14th subinterval. That's the standard agreement, the standard procedure for labeling these subintervals. Now, each of these has a width, a length of the interval, the width of this interval. So the question is, how far is it between x0 and x1? Well, on a number line, you take the larger number, subtract the smaller number, and we don't need to worry about absolute value. Since we're requiring these to be in sequence, we know that x1 is larger than x0, and so the width of this interval, what I'm going to call this is delta x number 1. Delta x is the width of the change in x, and subscript number 1. So delta x number 1 is the width of subinterval number 1, and it is given by x1 minus x0. Delta x number 2, the width of the second subinterval, is not necessarily the same as the first one. right? These are differing widths. And so x2 would be, delta x2 would be x2 minus x1, and so on down the list. If, in our other example here, suppose we wanted delta x number 14, then we know delta x number 14 is given by the right endpoint, x14, minus the left endpoint, x13. So this is the standard standard procedure for labeling these. And this continues on down. We would have delta x number 3, delta x number 4, and in this case, delta x5 would be the last one. Each of these is a certain width. The norm. The norm of delta is defined to be the maximum of all of them. I say delta x sub I, which means essentially all of them. So of all these delta x's, you pick the largest. That is the norm. It's possible that there may be 2 or 3 of them that are tied for the largest. That's fine. That's still whatever the maximum number is, that's the norm. In my not very well drawn picture here, it would appear that this is the maximum width. And so in this particular circumstance, it looks like the norm of the partition, the norm of delta, this is a delta, the norm of delta is given by delta x number 1. That's just coincidence because that's how I happen to have labeled this or chosen those points. Now the symbol for the norm is double absolute value. So this is the maximum of all the delta x sub i's, whichever the largest one is. If there's a tie, you simply choose the larger value and ignore the tie. All right. So that's the notion of a norm of a partition.